What's
Okay,
his
so
name?
today we're going to talk about
Do
Hey,
you hear
dude.
me?
2.7, the last section of this
Do you hear me?
chapter, linear inequalities in one variable.
You hear me?
How do
Hey,
we solve
no.
linear inequalities? Um, it will be a little different
Yo,
from solving equations.
it's
So let's
cool,
just
bro.
take a few examples first.
Mr. Lil.
Uh, no, I cannot hear you, Canon. I cannot hear you.
You can't
Can you
hear
hear
me?
me? I thought
Mr.
you
Lil.
guys can hear me now.
Hello?
Okay. Uh, but if yes, go ahead, please.
Do you hear me?
Canon? Yes, yes. What's your question? I cannot hear you. Can you tap in, or you can call my cell phone number if you want. But can we talk about after class? All right. Let's just finish this section, and we can talk about after class. Okay. So let's look at some examples of linear inequalities. How we can use inequalities to represent a number set. So we can have different notations for a set. We can use intervals. We can use inequalities. We can use graphs. There are different ways to do the same thing. All right. So we need to write the inequality to represent each interval in this problem, and then state whether the interval is bounded or unbounded. The first example is the interval from -3 to 5, where -3 is not included because we have a parenthesis on the left, and the 5 is included because we have a bracket on the right at the 5. So if you write this interval in inequality, it means all the numbers between -3 and 5, including 5 but not including -3. So we can write x greater than -3 and less than or equal to 5. And this interval is bounded because you know all the numbers are between -3 and 5. It doesn't go beyond all the numbers on the left or right. And part B is the interval from -3 to infinity. That means all the numbers greater than -3, including all positive numbers. So if we write that in inequality, it will be x greater than -3, not including -3. And this interval is unbounded because it includes all the numbers and all the positive numbers. So there is no bound. You can always find a greater number. If you pick up a number, you can always find greater than that in this set. Okay, so part C, from 0 to 2, all the numbers be from 0 to 2, including both x and 2. So we can write x greater than or equal to 0 and less than or equal to 2. So this interval is bounded because it's between 0 and 2. Part D, okay, I don't know why I put B in here. It's all the numbers, all the real numbers. So the numbers between negative infinity to positive infinity, that means all the real numbers. So we can write x greater than negative infinity and less than infinity. As I said again, I think I talked about this before. Infinity is not a number. Okay, it's just a symbol to denote that there's no bound. Okay, so it includes all the negative numbers and the positive numbers and 0, basically. So this interval is unbounded, of course. All right. So that's the notation for inequality. Let's talk about properties of inequality now. If you have inequality A less than B and you multiply a positive number C, then the inequality still holds. That means AC is less than BC. But when the number C is negative or less than 0, then the inequality reverses. So A less than B becomes AC greater than BC. Okay, so that's one thing you should be really careful about it. So we probably need to use this in property quite a bit when we solve inequalities. So in this example, we have 7x minus 3 less than or equal to 2x plus 7. So how do we solve this inequality? We just do a similar thing like we do in some equations, combine like terms. But we separate the variables on the left and the constants on the right. So we got 7x minus 2x or equal to 7 plus 3. You switch the terms to the other side, you change the signs. So then that becomes 5x less than equal to 10. Then you divide by 5 on both sides, you get the x less than equal to 2. Because 5 is positive when you divide by 5, you don't change the inequality or the direction of the inequality. So x less than equal to 2 is the solution. All right. Okay, let's talk about solving linear inequalities in one variable with more examples. So this time we got some fractions, but the way to do it is always the same. Okay, so we just solve 1 minus 3 over 2x greater than equal to x minus 4. Again, you group the terms or the like terms on one side and the other terms on the other side. So let's just subtract x, move x to the right side, to the left side, it becomes minus, and move 1 to the right, so it becomes minus 1. Negative 3 over 2x minus x is just negative 5 over 2x. You just subtract negative 3 over 2 and the 1. Negative 4 minus 1 is negative 5. Then you divide it by negative 5 over 2 on both sides. You get x less than 2. Negative 5 over 2 is 2. Negative 5 over 2x over negative 5 over 2 is x. So you can see we reverse the inequality from greater than equal to less than equal to 2 because we divided the inequality on both sides by a negative number, negative 5 over 2. All right. Okay. So let's do another example. We need to solve inequality 1 less than 2x plus 7 less than 11. That's called the composite inequality. It actually involves two inequalities. Okay. You can see the two less than signal symbols. So what we do, we can solve it step by step. For example, we can subtract 7 on each part of this composite inequality. So 1 minus 7 less than 2x less than 11 minus 7. And then that becomes negative 6 less than 2x less than 4. And then we divide by 2 on each part of this inequality. So we get negative 3 less than x less than 2. And because 2 is positive, so we keep the direction of the inequalities. So that means the solution to the inequality is all the numbers between negative 3 and 2, not the including negative 3 or 2. All right. So, okay. The last thing we want to talk about is absolute value inequalities. So this will be a little more complicated. We have two different cases. When you have absolute value of some expression u less than a, it actually tells that U is between negative A and positive A. So we assume A is positive. So for example, if you have absolute value of X less than 1, that means X can be both negative and positive as long as it is between 1 and 1. When you take the absolute value, you're going to get the absolute value less than 1, right? Okay. On the other hand, if you have the inequality absolute greater than A, and then that breaks into two inequalities. One is U less than negative A, and one is U greater than A. Again, let's say absolute X is greater than 1. Then again, A can be either positive or negative, because after taking the absolute value, you're going to get a positive number. So that breaks into X less than negative 1 or X greater than 1. So for example, X less than negative 1, we can pick negative 2 for X. Then you take the absolute value of 2, you get a 2, and that is greater than 1, right? And also, of course, if you pick up 3 for X, and then 3 is the absolute value of 3 is greater than 1, and the 3 is greater than 1 itself. Okay, so this is how you solve absolute value inequalities. So let's do two examples. And the first example is X minus 5, and the absolute value of that less than 2. So that's the first case. So U here will be X minus 5. So we can rewrite this absolute value inequality as a composite inequality negative less than X minus 5 less than 2. So in here A equals 2, right? And U is X minus 5. So we got this composite inequality, and then you just add 5 on each part of this inequality. You get 5 minus 2, which is 3 on the left, and 5 plus 2 is 7 on the right. So X minus 5 plus 5, which is X. So the solution of this inequality is just X than 3 and less than 7. Okay, another example. The absolute value of X plus 3 greater than or equal to 7. So that's the second case. A equal to 7 and U equal to X plus 3. So that breaks into two inequalities. It's either X plus 3, which is U less than negative 7 or negative A, or U greater than A, or X plus 3 greater than or equal to 7. So we have the equal sign here. We should keep the equal sign for each inequality. And this can be easily solved by subtracting 3 on both sides of both the inequalities. So we get the X less than or equal to negative 10, or X greater than or equal to 4. So that's the solution to this inequality. That's how you solve absolute value inequalities. So we just got a short section today, and so I guess I'm going to take the roll now, and let me just stay recording. If you don't, do you have any questions? No question. Let me just start recording.